Okay, hello everyone. I think we're all back from coffee. So, I'd like you. Can I get going? Okay. Or Keith can have a word.
Hi. Okay, welcome back to UK Off 34. So, first speaker after the break is Bert Hubert from Power DNS, and Bert's going to be talking about DNSdist.
That's it. Okay, thank you very much. So, in the next half hour, I'm going to do something horrible. We've been working on dnsdist, and I'll explain what it is for quite a while. And it turns out there is almost more about to say about it than be crammed in 30 minutes. So it's going to be quite a ride. So first, a little bit what we're going to talk about: Power DNS. Who am I? DNSdist. DNS is its important. Some of the things that we do, and we have some live graphs and demos, and then how to actually get the software. So to begin with, a little bit, Power DNS has always been sort of the ugly stepchild of DNS for some reason. We've been around for 15 years, and every time someone makes a list of big DNS people, we're not on that list. Not quite sure how that happened. Last year, we merged with a German company called Open-Xchange, which means that as a founder, where I used to do marketing and sales and HR and presentations and stuff, I'm now back to doing presentations and code, which is great. So who uses Power DNS? It's a lot bigger than people think. It's a lot bigger than I even think most of the time. We recently scanned the internet again, and we know that in Europe it's between 30% and 50% of all domain names are hosted on Power DNS. We scanned the whole .com and .net zone. The numbers there are a bit lower, between 25 and 20%, but still it's a big heap of things. DNSSEC, everyone sort of feels like, yeah, this is something we should be doing. Software that was out there originally had 25 million features for actually doing it, and we have historically not been in favor of DNSSEC, which has made sure that our implementation is bulletproof, because we were sure that people would get it wrong. So our DNSSEC implementation has basically one button called Secure Zone. And the embarrassing upshot of that is that we know that upwards of 75% of all domain names, and actually it's above 90% of all signed DNSSEC domain names are on Power DNS, which is an embarrassingly high number. Even though we power a lot of domains, we have a small percentage of the server base. That means because Power DNS deployments tend to be big. So if you scan around a little bit, it's not that much, it's a few percent, but those few percent count. The Power DNS recursor powers hundreds of millions of internet connections. So we have big cable providers, big nationwide carriers named after their country. So also there it's not that tiny. Very important for me. We are an actual open source business. So we write software, but we're not a charity. And it's great to be a charity, but it's also great that if you have sustainable software that is actually paid for by its users, and that's what we do. And finally, we're now together with Dovecot, the IMAP server with Open-Xchange. It turns out that the Dovecot people and we share a lot of users, and also we are both users of each other's software, so it's a good fit. Importance of DNS. I think you all know that everything you do starts with a DNS lookup. If the DNS lookup is a little bit slow, your entire internet is slow. Your mail will slow down, the browsers will slow down, everything's slowed down. The strange thing, however, is that DNS is one of the least measured protocols on the internet. People have graphs of responsiveness of their websites, they have graphs of the congestion and the queues in the network. But if you ask someone, do you know what the average latency of your name server is? Let me ask you, does anyone here have an idea of the average latency of their name server? Those are the good people. Thank you very much. We know. Yeah, we know. Ofcom here in the UK has been big on DNS latency, and I will be showing you lots of graphs that can make Ofcom happy. So it's one of the least measured protocols on the internet. People also, no one keeps logs of their DNS. At least no one used to, unless we had several changes in government. But no one made a log. There is no access log for DNS because people say, look, I'm logging 100,000 queries per second. This is going to be more work than actual DNS. So our observation really is that DNS in many circles is good enough. So as long as there are no complaints, then we're also not going to spend a lot of time measuring it. The upshot of this is that Jeff Houston has measured that 500 million internet users have managed to recover the password of their CPE or find that obscure panel in Windows and change their DNS to the Google DNS. Now, I'm not here to hate on Google DNS, but it is a sign that 500 million people around the world have found it necessary to change their DNS settings to get better service. So it's a big thing. So finally, what is DNSdist? We wrote a sort of mission statement for it, and it's actually true. DNSdist is a highly DNS and denial of service and abuse-aware load balancer. Its goal in life is to route traffic to the best server, delivering top performance to legitimate users while shunting and blocking abusive traffic. That's good stuff. In the process of delivering that, we added all kinds of other things because we had a framework that we could do it. So if you want to apply a regular expression to DNS and move traffic based on that, we have it. If you have misconfigured clients that there are too many of them to reconfigure and you want to fix them up in DNSdist, we have that. So it grew lots of features, so you can use it to detect infected users. So passive DNS is all the thing in security right now. It comes as sort of a side effect of running DNSdist. You can delay and rate limit bad queries. So if someone is using your name server, we've had printers sending thousands of DNS requests per second. They are slowing down DNS for the whole rest of your user base. If you want to say, well, the printer is going to be severely unhappy if I no longer send it any answers, but hang on, I'll just wait 200 milliseconds before I send it an answer. And suddenly the 1,000 questions per second it was asking us gets reduced to 5 questions per second, which is a nice way of sort of not killing the internet, but still solving your problem. Loads of statistics, like the kind that Ofcom cares about. It's open source, it's vendor neutral, so it's called DNSdist. It load balances and mangles DNS. It's not called Power DNSdist. So it's vendor neutral, and we've already seen contributions come in from various other name server vendors and operators, and that makes us very happy. And finally, it's pretty good at load balancing too, which is why we started it. The story of DNSdist, we really started it out as a way, can I just forward these DNS queries from here to there? And turns out that is a surprisingly hard thing to do. If you say, okay, this name server is down, but I want to send all the traffic to that other name server that is up, you can write 2 highly error-prone lines of IP tables, and you'll get it wrong. Or you can install a whole name server and hope that that name server, if you say it, forward the route to over there and hope that it will not mess with it. So this is how we started it in 2013. And in 2014, we had an interesting case. We had the biggest DNSSEC deployment of Power DNS. They had 700,000 domains on 4 servers. And there was a bug in there, and it was crashing all the time. And we were feeling really bad about that, but those people weren't. And they were like, yeah, well, we have 4 Power DNS name servers. We have a great load balancer. It hasn't happened yet that more than 2 of them have crashed at the same time. So they had a very relaxed attitude to DNS that we did not encounter in other places. So we asked around, is anyone happy with their DNS load balancer? So let me ask you, is anyone happy with their load balancing for DNS? I see 1 hand, I think, 2, okay. That matches sort of our experiences. Most load balancers are very good at HTTP. They know that stuff. DNS is sufficiently different from HTTP that if you come from an HTTP background and you're like, hang on, I can load balance DNS as well, that doesn't mean you'll get it right. And in fact, you'll frequently get it wrong. So, for example, a load balancer might send a query to see if your backend is alive, but send a non-recursive query to a resolver, which will happily not give you an answer in that case and declare your backend down. So they didn't do that good of a job. And we also had the quaint observation that a load balancer in the HTTP world will spread out your traffic. So if you have 5 backends, it will give each of one of them 20% of your traffic. Turns out that for DNS, the more traffic you give to one server, the happier everyone is, because you get vastly elevated cache hit rates when you do that. So if you have 5 servers and you give each of them 10,000 queries per second, you get far unhappier users than if you had one server with 50,000 queries per second and 4 servers that were idle, waiting to handle any kind of overflow. So we built DNSdist. What is it? It is, in essence, a DNS load balancer with heaping piles of policy. And we made it runtime configurable. So you can log in to DNSdist as it runs and ask it questions to see how are you doing. You can add backends at runtime, you can remove backends at runtime, and you can reconfigure it to your heart's content and inspect the current traffic that is flowing through. We could build this very rapidly on a small source base because we were able to use the wonderful programming language Lua as our infrastructure. Now, whenever someone hears that, either many people like Lua, but the other thing is people say, oh, it's going to be slow because you're using an interpreted language. 2 things. One, Lua is not slow. And secondly, we use Lua to configure DNSdist, but in almost all configurations, packets do not flow through Lua. Lua is the configuration and inspection language, but it's not the thing that does the actual load balancing for you, even though it could, because it's plenty fast. It powers the world of gaming. There are more people using games than doing anything else in the world these days, so it really is plenty fast, but still, we can do without it. We're all modern, so we have a RESTful API by which you can query it, and you can get statistics, you can figure out what it's doing, and we have a live website which you can use to look at your DNS traffic now. And why is that important? Almost all monitoring systems, at least that I know, give you an insight on the last 30 seconds or the last 5 minutes maybe. But if your name server is misbehaving, you need to know what is going on right now. And we provide features ranging from simple load balancing in round robin, but also you can use it to quarantine infected users, which is a nice way of making everyone happier. So some real life tests. So in the interest of time, I will go over this very briefly. I'll just show the graph. This is what you see. This is a typical graph that comes out of DNSdist. The blue line on top is the number of questions over a week. So it goes up and down, goes up and down. And the red line below is the average latency that we have measured. And from this you can clearly see that as the amount of traffic goes up, the latency goes down, which is sort of the inverse of what any web server will be doing. And we did an experiment with a big Belgian cable modem access provider. They had 4 name servers, and we shut down 3 of those and concentrated all their traffic on one server. This would naively lead, you would think that you would get 4 times higher CPU load on that one server. It turns out that the needle barely moved on that one server, because what simply happened, the number of cache misses on the server more or less stays the same. You only get the cache hits from the other 3 servers that go on top of that. So this means there is room for a load balancer in DNS that concentrates your queries on as few servers as possible. This, by the way, is output from our public, that's one powerful laser, wow. From our public graphing server. So all the PowerDNS products, you can tell them, send your statistics to this server and you will get these lovely graphs for free. And this is also this is tremendously helpful for you and for everyone, but it also helps us debug a lot. Okay, I'm going to skip over quite a lot. Why do people use DNSdist? You can just put it in front of your own name servers and get statistics. This is really nice. And you always learn something. This morning I deployed DNSdist in front of my own name server, and I found out there were all kinds of legacy domains pointing at it that I didn't know about. But it quickly shows up. IPv6, even though everyone says just deploy IPv6, it's not that hard. In some environments, somehow it is very hard. DNSdist is sort of a way to IPv6 wash your IPv4 only servers, because it will just proxy everything for you. You can add features to legacy DNS, so if you have any query attacks, you can move them to TCP/IP with dnsdist. You can concentrate queries. You can send abusive traffic to a abusive user pool, which is pretty nice. And you can also strip off DNSSEC when it doesn't work. This is something that the DNSSEC aficionados don't like, but on the other hand, we have to keep services running, so this is one of the things that we offer. Skip over this one. This is the simplest configuration. If you just say, okay, I just want to accept traffic here and I want to move it to there, you listen on one IP address and you forward traffic to these other IP addresses and you're done. This gives you a working load balancer with sensible load balancing policies and you're done. So while dnsdist is crazy powerful, if you just want to have some load balancing, enter the IP address on which you want to listen, where you want to forward to, and you are done. This is what a Lua configuration file looks like. So you configure the address on which you want to listen. You can create the access control list. You can create new servers, and in this case, each server has a QPS limit, which means that the first 1,000 queries per second go to the first server, the second 10,000 queries per second go to the second server, and any of the overflow goes to the third server. And this delivers you this concentrated load balancing behavior. This is what it looks like if you log in. So this is the console, and you can log in, and you can say show servers, and it gives you these live statistics on how all your backends are doing. It's pretty nice. You can also force a server down here, and then you can see it go down. Normally we probe it automatically to see if it's up or down. If you run these 4 commands, suddenly you get a live web server that reports statistics, and it looks like this. This graph actually moves. It's animated, but it doesn't animate in the PDF. But this gives you live insight in what your server is doing, and this graph moves around a little bit. Let's see, because it's so nice to see. Let's see. Yeah, it actually works. So this is what a live dnsdist display looks like. We have not found an actual operational use case for such a live graph, but it is so cool. So by all means, it's very. I mean, it gives people the feeling that you know what you're doing if you have a live graph. So you can connect to it over TCP/IP. It's all encrypted. You can also send commands to it. So if you have a whole bunch of DNSdists and you want to make a change to all of them, you can broadcast that. The configuration management is pretty nice. We have a command called delta. So if you've been configuring away on a DNSdist and it's just right, and now you want to serialize that configuration, would be great if you could say save, but that is a lot of work to make that happen. Delta gives you a list of all the configuration changes you made. So all the change commands with side effects, and you can just paste that at the end of your configuration file. So this helps you answer the question, I have this great configuration, but boy, what did we do to get it? Delta, that's what you do. Statistics, we mentioned that. This is a nice example of the latency graphs we do, and this was an unexpected side effect for us. This is the bottom graph is the distribution of queries over 3 backends, a green backend, a blue backend, and a red backend. And here we changed the load balancing policy to the smart one, the default one, least outstanding. And over time, DNSdist discovered that performance was best if it sent all the traffic to one backend. So at first, it sent the queries to the 3 backends, but over time, all the other ones lost out. And on the next graph, you can easily see why that happened. This is the latency for all the 3 backends, and you can see that the red backend consistently has the lowest latency. And that leads to a very favorable feedback loop, where the more traffic gets sent to this one server, the better it becomes. So that automatically leads to sort of scary, intelligent behavior. But you should realize the moment that this red server starts running a backup or whatever, it becomes a bit slow, then immediately it's no longer the favorable server, and maybe another one will get all of it. So this is nice. So this is the kind of per backend behavior you get. Policies, we have all of them. The biggest one is the least outstanding, which is the sort of magic one that picks the right server automatically. But you can also write policies yourself in Lua, and it surprises that people immediately started doing that. And they actually had some good reasons for that. This is an interesting one. You get traffic from users, and these users are abusing your system, but not to the point that you could actually go out and disconnect them. So you are an access provider, you're a BT or a Virgin Media or a TalkTalk or whatever. You have these users that send you abusive DNS traffic. If you disconnect that user, they will get on the phone with you and cost you a lot of money. But if you do not disconnect these users, they waste a lot of CPU cycles in your name servers and create generally unhappiness. What is the way to solve this problem? Because any big service provider has around 1 or 2% of users that are infected in some way and sending abusive DNS traffic. The best solution we have found to this problem, the very best solution would be educating those users to not get infected. We're working on it. In the meanwhile, what we have found is that if you can identify these 1 or 2% difficult users, you can give them their own name server, and they can ruin each other's internet experience. So you have this sacrificial server. You work on this server, you mess that one up, it's all yours. This is now deployed in what used to be the Czech Republic, but they renamed themselves to Czechia now, last week. So in Czechia, if you're a T-Mobile ADSL user and you have a virus, you end up on a very special server pool that's dedicated for you and your friends. QPS limit map is nice. This is from a Turkish university that had a scary large denial of service problem. And they simply said, we want to limit all our users to 5 queries per second on average. And if you exceed that, you are toast. So there's a command, max QPS limit. You can say, look, you're going to get 5 queries per second per /24. Or per /64 if you are on DNSSEC, an IPv6, and the rest will drop for you. Very briefly, no one logs DNS because it's an expensive thing to do. We have a protobuf-based logger. You can do this for security purposes. If you want to find out which of your users are infected, this is a great way to do it. There are also now governments that demand that you log DNS for a very long time. We're not in favor of that, but yeah, since we want our users to stay in business, this is how you do it. There's a cache in dnsdist. This is sort of the eventual thing that we were worried about, that dnsdist would turn into its own name server. It turns out that people have been very happy with this cache because it's very simple and very high performance. And it has the nice aspect that if you are under denial of service attack, which happens quite a lot, the dnsdist cache will just keep on sending answers because it doesn't think about your DNS a lot. And this has a sort of happy circumstance that as long as there are still good answers in the cache, your actual service will continue. We added a special mode to the cache where you say, okay, my backends are truly down. We are a host. Please keep the cache alive indefinitely, which means that you can take down all your backends and keep on serving from the dnsdist cache, which should at least keep most of your users happy because the cache will just never expire again. Again, this is an emergency thing, but it's quite fun. Generic rule action engine. This is where you say, these queries go over here. I told you that this morning I deployed dnsdist and I found out that a whole bunch of domains was actually still pointing at me. This add pool rule, for example, says, okay, sorry, these queries ended up here. They are in the wrong place. They should go over there. You can do many things here. Rules can match on source address, query type, query class. The QPS limit per IP address. Regular expression. The RIPE NCC asks us to implement RE2, which is a sort of regular expression with a better latency profile. And we thought no one would be using regular expressions on DNS. We thought, but of course someone then immediately did. It turns out that people use DNS to configure roaming profiles for 4G networks. I never knew. Normally you have to use whole domain names to say these people go over here, these people go over there. And then someone found that they could shrink their entire configuration to 10 times smaller if they simply said anything that matches this regular expression goes over here. So we built this and it got deployed. Actions, all the things you would expect: drop, route to pull, truncate, fake in whole answers. Yeah, the works. Dynamic rules are nice. This is where you detect that these are my abusive customers and I want to assign them to the abusive customer pool. So you can put your own policy in there. This is nice. This is the live traffic inspection. I promise you, if you deploy dnsdist and you issue these commands, it's a bit clickbaity, you'll be amazed what you'll find. You find old users that are still on your stuff. You'll find domain names that you thought you had phased out 5 years ago. It's a lot of fun to do this, and it never disappoints. And it's live, so it moves. It's cool. I love statistics. This is the response time latency distribution. So this is some real nice ASCII art. Performance, people say, this is so cool, and it's probably going to suck from performance-wise. We measure it up million to million queries per second on a single server. We use SO reuse ports. The wonderful presentation from BBC Research this morning, these techniques, like the end-top graphs, that's what we are doing as well. But we don't even need to right now. And to our sheer amazement, someone has taken down their Arbor deployment that used to be in front of their name server because dnsdist was up to their job. We did not build it for that, but apparently you can do it. Graphs never lie. So this is a 9-day performance run we did with this server currently doing 500,000 queries per second. And this big number here is actually 240 billion queries over 9 days. So yeah, we didn't make it up. It actually works. This is the important thing. DNSdist has been around for more than a year now. And people have been deploying it like crazy. And we never did a release, which is sort of stunning for us because I would normally not deploy unreleased software. So we've been telling people that we would be releasing DNSdist 1.0 for ages, and it should be happening right now. So let's see if they did the announcement yet. Let's see, did it go out? No, it did not go out yet. Apparently we are releasing DNSdist 1.0 right now. Maybe I should reload a bit. Yeah, there we go. We just released it, so congratulations everyone. You helped release DNSdist. You can read about it later. Okay, so it's there. I think some of you deployed it based on my pre-announcements here. That's nice. And you also contributed to making 1.0 better. Summarizing, we had this stuff. There's one brief thing I want to mention. Beware of geeks bearing gifts. We are a commercial company. We spend a lot of time building DNSdist. And you might wonder, are they going to take it away again? Or maybe turn it into some kind of pro edition. I think it's good to explain how we split this up. We are giving away DNSdist for free, and it's a true open source project with lots of contributors, and it's going to stay that way. How then do we make money? Because this stuff is not free. This briefly is the philosophy. We want to be very open in what we do. We are on the right side of this graph. We think that DNS is such a core component of your network that it needs to be an open thing. That doesn't actually mean that we have to give away everything for free. So this is the whole bunch of very good open source software. We are good friends with all these people. And what we see third parties that take this open source software, lock it down again in an appliance and add features to it. And we think that this is sort of a shame that you take all this lovely open source stuff and close it down again. The way we make money is we give away DNSdist and other stuff for free. You can build all these great things on it, but we also sell a thing called the Power DNS platform that has all these things actually in there. And in this way, we are able to give away this technology to all of you for free and share it with you, but still have the money to do full-time development on it. That was my DNSdist story. And thank you very much, and we have a few minutes left for questions, I think.
Hi Bert, Greg Chawles from 3UK. Last time you talked about dnsdist, I asked a question and we chatted afterwards about what you intend the software to actually run on. And we were talking about whether it would be possible to actually run it on the switch itself that your servers are physically connected to. I wondered if you'd sort of progressed that at all.
Yeah, so we did a lot of performance measurements to see if that was a useful thing for us to do, because it would get us dedicated hardware. And other stuff, and we have found that commodity PC hardware is actually going to outpace the needs of almost everyone we've interviewed. There's not a lot of people that do more than 1 million, with the exception of our Cloudflare friends here. Let me put it one. There are not a lot of people that do more than 1 million queries per second of legitimate DNS traffic. In terms of actual failover and reliability, we found that the best way to achieve that is to do the network-based load balancing, so with ExaBGP or OSPF or other things. So I think that compared to our previous presentation, we are now convinced that we can attain our performance goals on PC hardware, and that if you want to have the failover abilities of hardware, that it's best by doing that in the network layer. So.
Hi, Thomas Meng, Exanetworks. With PowerDNS, you can do answers which are based on source IP address, in effect, reply differently depending on who sends the query. If you put dnsdist in front, you will lose the IP address. So can dnsdist fake the IP address of the sender when you release a query, or does that mean you will lose it and you cannot put it in line?
So this is a very good question. One scenario that people have used dnsdist for is exactly the reverse of this problem, that you have lost the source address of a query already because your query has gone through carrier-grade NAT, which means that you can no longer apply per-user policies because you don't know who they are. So one of the modes of dnsdist is that it tags on the original IP address to the end of a query as an eDNS client subnet option, which then arrives at the recursor or any authoritative server, and it can do policy based on that tagged on IP address.
Thank you.
Okay, thank you, Bert.
Yeah, thank you very much.